Hello everyone, today we're going to be going over some sample problems for the 9th grade digital SHSAT. These problems are made by the Department of Education, which are the same people that make the digital SHSAT, and these are supposed to be the closest thing we have to real 9th grade math problems, right? So we're using the same software that you're going to use to take the digital test. Once you log on, you're going to be greeted by this exact message. You're going to press next, and we're going to start. Unfortunately, the DOE doesn't really make full-length 9th grade practice tests. I would love if they did, but all we get each year are 13 math problems, so I'm going to go over them. So the first problem asks us which of the following expressions is negative in value, okay? So for us to have something that is negative, we need to have a bigger number being subtracted from a smaller number. So when we do subtraction, if we have a smaller number here and we're subtracting a bigger number from it, this is going to yield a negative number. For example, 2 minus 3 is equal to negative 1. Okay, so in theory, this problem should be really easy, but they make it difficult by making the numbers in terms of pi. Okay, so for this problem, we just need to understand what pi is. Well, pi is an irrational number that's equal to 3.141519. It goes on forever, thus it's irrational. On the SHSAT, you only need to know that it's about 3.14. Okay, so with this knowledge, knowing that pi is 3.14, we can check which one of these answer choices is going to give us a negative answer. We're not given a calculator, so we can't plug this into a calculator. We'll just have to do it by hand. So choice A says that 4 minus pi has to be negative. Is that true? Well, if pi is 3.14, 4 minus 3.14 should give us 1.86, or somewhere around 1.86. So this is actually positive. It's positive because pi is smaller than 4. Right? And when we have the smaller number on the right side of the subtraction sign, that's going to give us a positive value. All right, so this is actually positive. Let's look at choice B. Here we have 3 pi minus 9. Is that negative or positive? Well, 3 pi is just 3 times 3.14, and then we're subtracting that from 9. And if we think about this, well, 3 times 3.14 is going to give us like 9.42, right? Or a number that's bigger than 9. Right? 9 is 3 times 3, right? 3 pi is 3 times 3.14. This pi is 0.14 bigger. So as a result, you're multiplying 3 by a bigger number, and you're going to get the bigger number on the left side, and 9.42 minus 9 is going to give us 0.42, right? So choice B is wrong because it's not negative. It's, again, positive, okay? Again, you don't even need to do the math here. As long as you understand that 9 is 3 times 3, and 3 pi is 3 times 3.14, 3 times 3.14 is going to be bigger, okay? Choice C, here we have 12 minus 4 pi. In this case, we have 12 minus 4 times 3.14. And here we kind of have the opposite situation as we had with B. 12 is 3 times 4, or we can say it's 4 times 3. And 4 pi is 4 times 3.14. So if we're multiplying 4 by 3.14, that's actually going to give us a bigger number than 4 times 3. So in this case, 4 pi is bigger than 12. And because we have the bigger number on the right side of the subtraction sign, this is going to give us a negative value. So the correct answer has to be C in this case, okay? You never had to do any of the multiplication. Only thing you needed to do is understand that pi is 3.14 and understand the relationship between multiplying a bigger number versus multiplying a smaller number. Multiplying the bigger number will give you a bigger result. If the bigger result is on the right side of the subtraction sign, you'll get a negative answer, okay? Choice D, 9 pi would have been smaller than 36, and that would have given you a positive answer. Okay, next. Over here, it says triangle ABC is graphed on the coordinate plane, and triangle ABC is reflected across the line y equals negative 1. All right, so first of all, when you have a line that has the equation y equals a regular number, for example, negative 1, that's going to tell you that it's a horizontal line going from left to right that passes through whatever it's equal to. So in this case, we have y, which tells me it's going to be a horizontal line, and it's equal to negative 1, which tells me it's going to pass through negative 1. So here we can draw a line that's passing through negative 1, going from left to right. So that's the line it's being reflected upon. And we know that it's creating image A prime, B prime, C prime. So now we have another triangle forming here because it's being reflected across this line. And now, out of all 4 of these choices, we want to select the triangle that's oriented properly, and we want to go ahead and drag it onto where we think it should belong on this on this coordinate plane, okay? Let's go ahead and do that. So when you have a reflection, all you're doing is you're bringing the points down to the line of reflection and then back out from the line of reflection, Okay, so if you're reflecting this triangle over this line, that means you're going to take every single point. So for example, point B, and you're going to move it down to the line of reflection. So point B is 1, 2, 3. So it's 3 units down to get to the line of reflection. And then in order to actually reflect it, you're going to move that point from the line of reflection the same distance that you had to move down to the line of reflection. So in order to go down to this line of reflection, we had to move 3 units down. So to get the reflected image, we just move 3 units further down from this line. So 3 units further down is 1, 2, and 3. So we know that B prime has to lie in this position, right? We went 3 units down to get to the line of reflection, and then we just keep going the same amount down. Okay, so B prime has to lie there. Okay, now let's do the same thing with the other points. Okay, no math involved, just you could do this visually, right? If you want to do the math, you could just take the y coordinate of B, which in this case is 2. You know that from 2 to -1, you have to go 3 units down. And then from -1, you could subtract 3 to get -4. So now you're at -4. You could have also done it with that, right? Take the starting point, figure out what number you have to subtract from it to get to the line of reflection, which is -1. X would have to be 3. And then from the line of reflection, plug that number in, subtracting from it to go further down. All right, if we do the same thing with C, C is 1, 2, and 3 points away from the line of reflection. So starting from the line of reflection, we're going to go down 1, 2, and 3 points to get C prime over there. Okay, and the last point that we need to look at is point A. But if we're trying to save time, there's only one answer choice here that could possibly be correct, which is this one, because it puts B and C across from each other like this. And we can just drop it on top of the points that we drew there, and now we have the perfectly correct reflected image. Okay, so because we already plotted B and C down, we technically don't even need to plot or calculate where A is, because as long as we align this triangle with B and C, A will be in the correct position, okay? And technically, we could have stopped with B, right? As long as we just knew where B was going to go, we could have selected this shape and then just dragged it down to the right position, all right? That's all we need to do to solve this problem. Moving on. And also, before you guys get scared about problems like these, this is no different than a regular multiple choice problem on the 9th grade SHSAT. This digital SHSAT isn't making up new math problems. You don't need to know new math. They're just they're testing you the same exact material they would on the 9th grade SHSAT, but instead of you selecting A, B, C, or D, or putting it in a grid in, you're now selecting your answer choice by dragging a shape somewhere. It's the same math, right? Traditionally, this would be a multiple choice problem, and it would say like choice A would say that A prime is at 3, 2, B prime is at 6, 2, and C prime is at 4, 6. And you just have to select the correct answer choice that had the correct coordinate points for the reflected shape. That's the only difference here. Instead of asking you that, they just ask you, okay, we'll plot it directly. Okay, so it's the same type of problem. Moving on, it says that the symbol of x, y, z means to put x times z plus x plus y, plus x times y over 2 plus xy. So essentially, this is what we call symbology, right? The same way that a division sign, for example, 6 divided by 2 is 3. 6 divided by 2 is the same thing as 6 over 2. This math symbol we know to be the division symbol. The division symbol tells us, if we have A divided by B, the division symbol tells us to put A in the numerator and B in the denominator and then evaluate that. So in this case, we always use division, right? This is a well-known symbol. But this is a made-up symbol that they did, and it essentially serves the same function as this division symbol here. It tells us a rule. It tells us that whenever you have x, y, and z arranged as x is the first number, y is the second, and z is the third, in order to evaluate this, this is the same thing as putting x and z together and multiplying them, adding them to x and y and multiplying them, and dividing the whole thing by 2 and then adding it back to z and y. Okay, so just how the division symbol tells you to put the first number in the numerator and the second number in the denominator, this now tells you what to do with 3 numbers, okay? So it's a symbol, it's a math symbol, and we just need to evaluate it. So let's look at what goes where. So the number in the first position is going to go here to replace x. It's going to go here in the numerator again. The number in the second position is going to go right here, and then it's going to go right here. And finally, in the third position, it's going to fill in right here and also fill in right here. So to evaluate this, just plug in the values as they appear here. So we know that 3 is in the first position, so that's x. 4 is in the second position, that's y, and z is in the third position, so 8 has to be z. All right, now plug it in. X is 3, so we have 3 times z, which is 8, plus x is 3, and y is 4, so plus 3 times 4 divided by 2, plus z times y, z is 8, y is 4. So 8 times 3 is 24, 3 times 4 is 12. So 24 plus 12 is 36. Sorry, that's 36. Divided by 2, plus 8 times 4. 8 times 4 is 32. So here we have 36 over 2 plus 32. 36 over 2 is 18. 18 plus 32 is going to be what? That's going to be 50, right? So the correct answer here has to be 50. That's all we had to do, all right? Just know that this is symbology. It looks difficult at first, but as long as you're able to relate the variables to the numbers that you're plugging in, just know that x equals 3, y equals 4, z equals 8. That's all you needed to do here, and to plug it into this expression. All right, moving on. It asks us to simplify p to the power of 12 times p to the power of 0 over p to the power of negative 4. So over here, I know that whenever I have any number to the power of 0, for example, 1 to the power of 0, 2 to the power of 0, 8 to the power of 0, p to the power of 0, all of these are going to equal 1. Anything to the power of 0 is equal to 1, okay? So p to the power of 12 times p to the power of 0 is the same thing as saying p to the power of 12 times 1, or just p to the power of 12, because anything times 1 is itself, okay? That's a quick rule to save time. Then, you know, whenever you have a to the power of b over, let's say a to the power of c, and you're dividing these two, that's the same thing as saying a to the power of b minus c. So instead of keeping this as a fraction, you can actually simplify this because they have the same base. Remember that we have the base, which is the variable or the number, and then we have the exponent, which is the smaller number or the smaller variable. So when we have p to the power of 12, p is our base, 12 is our exponent. When I have p to the power of negative 4, p is the base, negative 4 is the exponent. So because they have the same base, because a and p are the same thing, we can write the exponents under the same base, or under one base, p, and we can combine or work around these two exponents by taking the numerator's exponents, which is 12, right? Writing that down first, and then from that numerator, subtracting the denominator's exponent, which is negative 4. So here we have 12 minus negative 4, okay? Remember that we're subtracting negative 4. Whenever you see two negative signs, for example, minus, minus, that's the same thing as saying plus. Remember that in order to make a plus sign, you need two lines. The two lines come from the two negatives. So this is actually p to the power of 12 plus 4, or p to the power of 16, which is choice D. Okay, so just remember your exponent rules. Moving on, it says that a container initially contains n gallons of water, and we know that a student adds 15 gallons of water, making the container 60% full. And then after the student adds 10 more gallons, and the water becomes 80% full. So select the correct answer choices from the drop-down to complete the sentence. So again, this is the same thing as a multiple choice problem, because the drop-down gives you multiple choices, right? So it's not like a grid-in where you have to type in an equation. This is kind of 3 multiple choice questions combined into one. Again, the content here is the same thing you'd see on the SHSAT. There's just more steps involved. So you're still choosing multiple choices, so this is still a multiple choice question. Instead of A, B, or C, they just give you the numbers for you to select from a drop-down list, okay? All right, so here they're asking us, let X represent the total number of gallons that each container can hold. So X is my total capacity, and it says that the equation that represents the situation immediately after the student adds 15 gallons of water is what? So the initial situation says that a student adds 15 gallons of water, making the container 60% full, okay? So in this case, N is the number of gallons that the container currently holds. So that's the current capacity. So the container, let's just say it's like an oil drum or whatever, has n gallons of it, right? So the water level is like this, right? And this is n gallons. Then the student's going to add 15 gallons of water to that. So then we're adding 15 more gallons of water. So we're left with n plus 15, which they've already written here. Now, when the student adds those 15 gallons of water, the container is 60% full. So this n plus 15 is 60% of what the container can hold. So if the container can hold X total gallons, 60% of the total capacity is full. That's 60% of x. Whenever you're finding the percent of something, that's the same thing as replacing of with a multiplication symbol. So 60% of x is the same thing as saying 60% times x, or 0.6x. So adding 15 gallons to the total, or to the current volume, is the same thing as finding 60% of the total volume. So that's this. Then the second question here asks us the same thing. We know that when the student adds 10 more gallons of water, so we added 15 and then we add 10 more. 15 plus 10 is 25. That's where this 25 comes from, right? We already had 15 gallons being added, and then we added 10 more to 15, which is 25. So when 25 gallons are added, the container is 80% full. So 80% of the full container, which is x is the capacity of the full container. 80% of x is just 0.8x. So this is equal to 0.8x. And finally, we have two equations. We have that n plus 25 is equal to 0.8x, and we also have n plus 15 is equal to 0.6x. They want us to find the number of gallons n that is initially in the container. So if I have two equations and I'm trying to solve for one of the variables, well, I can't, right? Because if I have two equations and they have two different variables, it's impossible at this level to solve for one of the variables. I need to eliminate one of them. So by eliminating them, or by writing my equations above one another like this and subtracting them from one another, I can eliminate n from the equation and I can get the total capacity. Okay? Hear me out. When you have two equations, always write them on top of one another so that you can subtract them. So here, I can subtract each term individually. So n minus n is equal to 0, right? There's nothing here. So these two cancel out. 25 minus 15 over here is equal to 10. And we have 10 is equal to 0.8x minus 0.6x, which is 0.2x. Okay? So now we have that 10 is equal to 0.2x. If I divide both sides by 0.2, I know that x is equal to 50. Right? So the total capacity here is 50 gallons, okay? Now, am I going to go ahead and select 50? No, that's a trap answer because x is the total capacity. I want the current capacity. So now that I know what x is equal to, I can plug that x into any one of these two equations. So let's just do this one. I have n plus 15 is equal to 0.6x. I know that x is equal to 50, so I can say that n plus 15 is equal to 0.6 times 50, and that n plus 15 is equal to 30. And if I subtract both sides by 15, I get that n is equal to 15. So the current capacity has to be 15 gallons, okay? Now, did you see how eliminating one of the two variables lets me solve for the value of the other variable, which lets me solve the problem? This is something that's going to consistently be on the 9th grade SHSAT. This is something called system of equations, okay? When I took this test, when I took the 9th grade SHSAT, it was pretty much like more than like 10 questions or like more than 5 questions. I took it a while ago, but I remember there being a lot of system of equation problems. A lot of them, the solution was to just combine the two equations on top of one another and then subtract or add them to eliminate one of the variables. Right? And then just solve for both of them by plugging in the variable that you solved for back into one of the two equations. So this is a very valuable technique. This problem, all in all, was not that hard. You just needed to convert the math into English, and then the real math or the real problem that we had here was these two equations, or were these two equations. Okay, moving on. It says that straight line L passes through the origin as shown in the figure above. What is the slope of line L in terms of A and B? So if it's passing through the origin is always 0, 0, and we know that the slope is equal to the change in y over the change in x. So delta is just equal to final minus initial of whatever we're looking at. So delta y is equal to the final y minus the initial y. Okay, or it's just y minus y to find the change. So let's say that if we look at any, and you can calculate the slope for any points, and delta x is the same thing. That's just the final x minus the initial x for any point. And oftentimes you see the slope being written as y2 minus y1 over x2 minus x1. So you're looking, in order to calculate the slope, you need to have 2 points. So find any 2 points. Make one of those points y2, x2, make one of those points y1, x1. So say that one of your points is the end point and one is the beginning. If I look at this graph, I have the origin, which I know is 0, 0, and I have my second point over here, which is a, b. So if I look between these 2 points, I start at 0, 0. That's my initial x, or my x1 and my y1. And then I go up and I stop at a, b. So a is my final x, that's x2, and b is my final y, which is y2. So now that I've assigned and ordered my points, I can just plug them into this equation, right? I have y2, which is b, minus y1, which is 0, divided by x2, which is a, minus x1, which is 0, and this turns into b over a, which is my slope. Okay, that's going to be choice D. You could have also done the same thing with a different point, right? You could have done the same thing choosing a, b, choosing a, b as your first point, and then 2a, 2b as your second point, right? I just think that choosing the origin would be faster because subtracting 0 from anything requires no math. Whereas subtracting 2a minus a, you kind of have to think about it and know that it's just a, and then subtracting 2b minus b, which is bb. Okay, remember that slope is y over x. So you're subtracting the y first and then putting that over the x. Don't flip it around. And that's all. Just pay attention to how you label your points. Moving on. We have that a scatter plot displays the number of cars sold each month at a dealership over the past year. A student has drawn a line of best fit to model the data and wants to determine whether the line accurately represents the data. Which two characteristics of a line of best fit which two characteristics of an accurate line? What are two characteristics of an accurate line of best fit for the scatter plot? So essentially, a scatter plot, it's in the name, right? It's a plot where all the points are kind of scattered around, and they're not connected by a straight line, right? This is often when you have like a bunch of raw data points, you plot them like this, and a lot of computer programs are out there, and what they do is they try and find a trend for the data points. So if I look at the data points over here, you can kind of see a trend, right? Essentially, as they go further out on the x-axis, they end up going higher on the y-axis. So a line of best fit could be drawn to model this data. So instead of having a bunch of random points on the graph, and you kind of have to see that as x increases, y increases, the computer program will automatically draw a line for you that kind of closely hugs the points, okay? So that's a line of best fit, and it doesn't always have to be a computer, a human can draw that, but a line of best fit just has to model what is happening in the data. So if this is, let's say, like temperature, temp, right? And this is sales of ice cream. As the temperature increases, let's say over here it's like 60 degrees, over here it's like 100 degrees. As the temperature gets hotter, as it gets hotter outside, the number of ice cream that you sell, let's say here's 5 and here's like 100, the number of cones of ice cream that you sell increases. And that should make sense because as it gets hotter, people want to cool down and go outside more, and they buy ice cream to cool down because it's a nice day or it's a hot day, right? So the way that we mathematically plot that out is by drawing a line that passes as close to the points as possible. A line of best fit doesn't actually need to pass through any points, right? It could, that's a benefit, but it doesn't have to. So if I have a more accurate spread of data over here, a line of best fit just needs to go as close to the data points as possible, and a good rule of thumb here is that a line of best fit will have the same number of points above the line as below the line. So here I have 1, 2, 3, 4, 5 above and 1, 2, 3, 4, 5, 6 below. So as long as these two numbers are pretty close together, you know you have a good line of best fit drawn, essentially. So it's a line that shows the trend of the data, the relationship between x and y, that also passes closely through the points. Okay, it doesn't have to pass through the points, just has to pass close to them. Let's look at which one of these two choices matches that. So choice 1, the line of best fit is accurate if it passes through at least one of the data points. That's false, right? You can see here that it's a linear relationship, but a student can draw a line of best fit incorrectly, and he can draw the line going down like this. Sure, that line passes through one of the points, but it's in the wrong direction, and it's saying that well, actually, I don't know what it's saying, right? If we extend it like this, it's saying that as the temperature increases, the number of ice cream sales would decrease, which is not what our data points here show, okay? So that's wrong. We're not selecting that. 2, the line of best fit is accurate if about half the data points are above the line and half are below. That's true. that's a good way of testing whether or not the line passes close by the points. If the line is close to the points, that means that you have an equal number of points above and below. 3, if the line of best fit is accurate if it touches every single point of data, that's false. A line of best fit, oftentimes, and we're talking about the 9th grade SHSAT, the line of best fit is going to be a linear line for you guys. It's going to be a straight line. If you have data points, it's kind of impossible to connect all of the lines or all of the points on a scatter plot without that line not being straight and being all jagged and crazy like this, right? So that's false. You don't need that. So the line of best fit would not be accurate if it touched every single data point. It wouldn't be a line of best fit. It would just be a squiggly curved line, which is not what you're looking at for a line of best fit on the 9th grade SHSAT. Okay? This point right here, the line of best fit should always pass through the origin. This is false. That's not a requirement. And finally, last choice, the line of best fit should capture the overall trend of the data. That's the whole point. All right, we're going to move on. So to determine the price of servicing a car, a mechanic charges a fixed fee. So let's call this fixed fee F. So we have a fixed fee that always gets applied, plus, which means adding that, in addition to an hourly rate for each hour he works. Okay, so plus this hourly rate for X hours. Okay, 4 just means multiply. So hourly rate, which is my R, times each hour he works for, X is my hours. Okay, so we have our fixed rate, which he'll always charge no matter how long or how short he looks at your car for, plus R times X, okay? If his price for 4 hours of work is $270 and his price for 7 hours of work is $420, what is the fixed fee, okay? So in this case, we have two equations that we're going to end up writing. We have our fixed fee plus 7 hours of work. So 7 times R. So he worked for 7 hours. Each hour, he's going to charge a rate. So you're going to add the rate 7 times because each hour he works for, he charges a rate, and there's 7 hours. So this ends up becoming 7R. So you have F plus 7R is equal to $420, and then F plus 4R is equal to $270. I'm going for 4R right here because he also works for 4 hours. And again, we have a system of equations. We have two equations. We cannot solve for F or R when they're together, so we'll have to eliminate one of them. The easiest way to eliminate is always going to be subtraction. So if I subtract these two equations from one another, F minus F cancels out. 7R minus 4R is equal to 3R. And finally, 420 minus 720 is equal to 150. So that means that R is equal to 50. Now, is that my answer? No, because this is my hourly rate. Now that I know my hourly rate, I can plug it back into either one of these two equations to get my fixed rate. So let's plug it into the bottom equation, right? Here I have my fixed rate plus 4 hours, and for each one of those hours, I'm charging $50. That's my hourly rate, and that's equal to 270. So F plus 200 is equal to 270. So F has to equal 270. That's my fixed fee. So that is choice C, right? Moving on, it says rectangle PQRS is rotated 180 degrees around the origin. What are the coordinates of point R? You know that whenever you have a 180 degree rotation, that's taking your X and your Y, and then once you rotate it, it makes both of those negative. So a 180 degree rotation turns XY into negative X, negative Y. So the coordinates of point R, right, is right here. And it forms a rectangle PQRS, so PQRS. Once I rotate this rectangle 180 degrees, it's asking me for the resulting coordinate of point R. Right now, point R lies on the coordinate 4, 3. 4 is the X, so 1, 2, 3, 4, and then it's 1, 2, 3 above the Y-axis. So that's 4, 3. So if I have the point 4, 3 and I rotate it 180 degrees, that's going to turn into the point -4, -3, which is choice D in this case. All right. So it's asking us what is the quotient of the expression above expressed in scientific notation, okay? So in this case, we need to understand what scientific notation is. Scientific notation is a way of expressing really big or really small numbers in terms of 10 to the power of a number, okay? So let's say that I have, the following number, like I have 231,000. Right? It's a pretty big number. It would be annoying to write this on a page that you have limited space on. So we have a system called scientific notation that will write this as 2.31 times 10 to the power of 4, okay? And essentially, if I had like 0.000000001, this is a really big number, but I can write that as 1 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 10 to the power of negative 8, right? So it's a way of making bigger numbers smaller. And essentially here we have, in this format, we have the number. This number always has to be between 1 and 10. So it has to be less than 10 but bigger than 1. And finally, this number right here has to tell us how many zeros are going to be behind the decimal point or in front of the decimal point, okay? So let's look at this problem. Now we have 15.3 times 10 to the power of negative 8. Because this is negative 8, I know that there's going to be 8 zeros in front of this decimal place. So if you were to draw out the zeros, there'd be 1, 2, 3, 4, 5, 6, 7, 8. The zeros would go all the way out here. And that's being divided by 1.5 times 10 to the power of 4. The positive 4 here tells me that the zeros are going to go behind the decimal place in this direction. The cool thing that we can actually do here is we can split this up into two different fractions. This is something that you could always do with fractions. For example, 2 times 3 over 2 times 3, we can essentially split that up into 2 over 2 times 3 over 3, and we'll get 1 for both of these, right? So it's just a thing that you can do when you have two numbers being multiplied in the numerator and two numbers being multiplied in the denominator. So I can split this into 15.3 divided by 1.5, or 15.3 over 1.5, times 10 to the power of negative 8 over 10 to the power of 4. Okay, and now I can just evaluate both sides individually. So 15.3 divided by 1.5, in order to make this division, what I can do is I can move both of these one decimal point to the right and just divide 15 by 153. When I do so, what I'll get is 102. Okay, so 15 goes into 15 one time, and then we drop down the 3. Once the 3 gets dropped down, 15 goes into 3 0 times. Because we added a 0 here, we call down for another 0 to come down, and 15 goes into 30 2 times. So 15 goes into 15.3 1.02 times, right? So because you moved the decimal point, you now have to move the decimal point back. So we had a 102 here originally, but remember that we moved the decimal point back 1 and 2 places. So now we have to do the opposite. We move it back 1 and 2 places to get an answer of 1.02. Okay? So yeah. Or actually, we only move it back one time. Sorry, guys. We move it back for however many places we moved it back for 1.5. So 1.5 goes into 15.3 10.2 times. Okay? And you can test that out by multiplying these two together. So now this end, or this side of the fraction here, is equal to 10.2. Okay? And we're multiplying that by 10 to the power of 8 divided by 10 to the power of 4. Notice here we have the same base, so we can combine this or rewrite this as an exponent under one base, 10, and in the exponent here we can have the numerator negative 8 minus the denominator 4, and this turns into 10 to the power of negative 12 if you remember those exponent rules. The issue here is that 10.2 is now greater than 10, so this is no longer in scientific notation. In order to convert this into scientific notation, I now need to make this less than 10, and the way I can do this is by moving the decimal point, and that's always how it is in scientific notation. You're going to move the decimal point. So if I move the decimal point back, I will essentially be increasing the value of this exponent. But if I move the decimal point back, I get 102, which is even bigger than 10. So I'm going to have to move the decimal point in the opposite direction. I'm going to have to move it in this direction, okay? So essentially now I'm left with 1.02, and because I moved the decimal point in the right direction, I'm going to have to make this smaller and make this 10 to the power of negative 11, which is going to be choice B, right? Because as of now, right, when I have 10 to the power of negative 12, that means that I have to move my decimal point 12 times in this direction, right? So 12 times, that's once, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But when I've already moved my decimal point in this direction once, to make this match the scientific notation format, I now have to move my decimal point in that direction one time less, because either way, this times 10 to the power of negative 12, this decimal would have had to be moved to where it currently is. So now I need to move this one less step because I'm already closer to where my decimal point needs to be if I wanted to express this number fully, because I had to reformat it. Okay, so this becomes 10 to the power of negative 11, which is going to be choice B. All right. So over here we have a system of linear equations. We have 2x plus y is equal to 5 and x minus y is equal to 1, and they want us to graph the set of linear equations, okay? So again, don't panic when you see this. This is a problem that could have occurred on your normal on your regular paper SHSAT. The answer choices could have just been 4 different graphs, and it would have been your job on paper to figure out what this system of equations looks like, and then match it up with the answer choices, which would be different graphs, right? Now, instead of matching it up with different graphs, you're just going to graph it yourself, which is no more work, right? It's not extra work for you to do. So in order for you to graph something, you should put it in terms of y, because you have y equals mx plus b, right? So if I have 2x plus y is equal to 5, the way that I can graph this is by putting everything in terms of y. So if I subtract 2x from both sides, I get y is equal to 5 minus 2x. And then from here, I can just find 2 points, right? So if I say x is equal to 0, right? If x is equal to 0, that means that y is equal to negative 5, because y would just equal to 5, sorry. Right here. Because 2 times 0, negative 2 times 0 is 0, and then you're just left with 5. And then let's just make y equal to 0. So 0 is equal to 5 minus 2x, and then maybe that's not so good of a choice, actually, because then we have a decimal. So my point here is that in order to graph something using the software, you need to put it through 2 points, essentially. Okay, so you can find those 2 points, if you're lucky, by making x and y 0, and then matching that with the correct coordinate. So I know when x is equal to 0, y is equal to 5. So this is the point 0, 5 that we just found. Okay, that's that. So if I went ahead and graphed line 1, I can put my first point at 5, 0, and now I just need to find my second point. Okay, and over here it would be helpful if we could find our second point by making y equal to 0 and getting a whole number as our answer, but unfortunately we can't. So in order to complete this, what we can do is we can look for a different point. Let's say we can make y equal to, let's say, 15. Or actually no, because y has to be between 0 and 7, and x has to be between 0 and 7. So for this, a quick trick that you can do is you know that your slope is equal to rise over run. So it's the amount that you go up or down by versus the amount that you go across by. So in this case, the slope is always a number in front of x. So here we have negative 2 in front of x, so my slope is equal to negative 2. That means that my rise over run is equal to negative 2 over 1. So from my first point, in order to get to my next point, I'm going to have to rise by negative 2. If you're rising by a negative number, that technically means that you're falling. So you're going to have to go down by 1, 2 points, and you're going to have to run or go to the right by 1 point. So this is actually the line of my first graph, and now I'll have to do the same thing for my second graph. So here I have x minus y is equal to 1. So I can do x is equal to 1 plus y, and then subtract y on both sides and get x minus 1 is equal to y. So here, another trick you can do is y equals mx plus b. This is going to be the y-intercept. So essentially, the number that's right here is going to automatically give you a free point. So this point is going to be negative 1, and the y-intercept is always on the y-axis. So you can just put that point on the y-axis as negative 1. And now we'll just have to find our second point. So over here, well, there's no number in front of our x. So what could our slope be? Well, remember that technically there's a 1 in front of this x, which means my rise over run is 1 over 1. So I'm going to rise by 1 or go up by 1 and then run to the right by 1. Okay? I'm going to go up by 1 and then rise and run. I'm going to rise by 1 from this point and then run to the right by 1. And essentially that's my second line. And finally, the solution is where the two lines intersect, which is going to be right here. That's all you have to do to solve this problem. All right. Assume s of x is equal to the sum of all positive even integers less than or equal to x. What's the value of s of 7? So an even integer, well, first of all, an integer is a whole number that could be negative or positive. Essentially, it's a number that doesn't have a decimal. So, for example, 2.5 is not an integer because it has a decimal 0.5. 1/3 is not an integer because this is equal. This is a fraction. No fractions are integers, but also 1/3 is equal to 0.3 repeating. So that's a fraction. So integers are numbers like 1, 2, 3, 4, and 5, right? So s of x is equal to the sum. The sum is just adding numbers, and it's the sum of all positive even integers less than or equal to x. So x is my limit, and we're going to add everything starting from essentially 0 going up to x together. So if I'm looking at s of 7, that's the sum of all positive even integers less than or equal to x. So let's look at positive integers. We can start at 0, 1, 2, 3, 4, 5, 6, and then it's the sum of all positive even integers less than or equal to x. So in this case, my limit here is 7, okay? Now, this is gonna, s of 7 says that look at all the positive numbers starting from 0 going all the way up to 7, right? And then 7 is my limit, add all of the even numbers between them. So in this case, the number of even numbers, well, 2 is an even number, 0 is an even number, 4 is an even number, and then 6 is an even number. So s of 7 tells you to list out all of the numbers that are whole and positive going from 0 to 7, and then add the even numbers that are there. So here we have 0 plus 2 plus 4 plus 6, which is 6 plus 6, or 12, okay? And that's going to be your answer, right? So this is, again, a common type of problem on this test. It's not hard. The only math you have to do here was addition, but just know how to translate the math into English, and you'll be good, right? So you're going to find the sum of the positive even integers. Positive means it's not going to be negative. Integer means it's not going to be decimal, so you're literally just counting 1, 2, 3, 4, 5, and they're going to be all of them that are either 7 or less than 7, which we wrote here. 7's not a whole number. Sorry, 7's not an even number, so we don't have to add it. The biggest one is 6, then 4, then 2, and that's it. We add them together. All right, so in the figure above, MPR is similar to NPQ. If the length of NQ is 10 centimeters, what is the length of MR in terms of x? So we have two triangles. We have MPR, which is over here, MP and R. And then we also have NP and Q, which is this. So we are left with two triangles, and they're similar to one another. They're similar because there's some sort of relationship between them that can turn this black triangle into this pink triangle, and this pink into this black triangle. Okay, then we also know the following. We know that the distance between N and P is 5 centimeters. All right, and the distance between M and N is X, and then we know that N and Q is 10, and we want to find the length of MR. So we're looking at the length of MR in terms of X, okay? So whenever you have similar triangles, you're just going to have to relate the sides, okay? So relating the sides just means writing the sides down in a format where they're equal to one another. So we know that what sides are equal, or what sides correspond, right? If these are similar triangles, what sides are similar? Well, I know that N and P, or NP, right here, is going to be similar to MP, right? This side right here on this triangle, on this small black triangle, is similar to this bigger side on this pink triangle. Why are they similar? Well, they occupy the same side. The only difference between NP and MP is that MP is bigger. So NP is similar to MP. NP is similar to MP. They go in the same direction. One is just longer than the other, okay? So we can write them equal to each other like that. Then the second step is to find another pair of sides that are similar. And, well, we can see that NQ right here, belonging to the smaller triangle, is similar to MR, which is this longer side belonging to the bigger triangle. And notice here that I have both of the sides that belong to the black triangle under one another. you must have this, right? The sides are corresponding across the equal sign, and underneath them are more sides from the same triangle. And just like this, I now have a proportion, right? From here, what I can do is plug in values. I know that NP is 5, and I know that NQ is 10. I know that MP is x plus 5 because we have to add this x to this 5 to get x plus 5. And finally, I'm solving for MR, so I'll keep it the same. And now what I can do is I can have 5MR be equal to 10 times x plus 5 because I'm cross multiplying. And here I have 5MR is equal to 10x plus 50, and then I know that MR is equal to 2x plus 10, which is choice B. So again, similar triangles, it's a simple concept, right? You look at the sides that are similar to one another. NP, MP are similar, so you write them across from one another. Then you write another pair of sides underneath those two, right? NQ and MR are also similar, so you write them across from one another, but underneath the same side that they belong to. So ultimately, these two belong to the pink triangle, and these two belong to the black triangle, which is why they're underneath one another. And then to solve, you can just cross multiply. That's question 13 out of 13. I wish that they had released an official 9th grade practice exam. That would be the first test I'd go over. To all my viewers taking the 9th grade SHSAT, I wish you the best of luck. Don't stress it. In terms of practice, you have these problems. You have essentially 9th grade sample problems all the way up to the 2008 SHSAT student handbook that you can use. They're all accurate, they're all challenging, and they'll prepare you for the 9th grade math section. Just remember that 80% of the 9th grade math section is the 8th grade section. It's just they add these extra questions that are kind of tricky for 8th grade students into the 9th grade SHSAT for you guys to solve, okay? So I hope you guys learned something from this video. If you have any questions, please let me know in the comments down below. For more 9th grade sample problems, check out my 9th grade SHSAT playlist. Again, any questions, leave them down below. Best of luck to all of you taking the test. You guys got this. Hope you learned something, and I hope you have a nice day.